Hello everyone. In this video, I'm going to discuss on a unique topic. It is most interesting for mostly geophysicist persons, whoever, especially explorers and geologists, whoever involved in field. And in case of electromagnetic exploration, electromagnetic survey, they often come across a particular term, a particular concept that is called skin depth, that is regarding electromagnetic signal attenuation. So we'll be trying to understand what is skin depth and what are the basic fundamental principles behind that. First, preliminary introductory, if we see some basic thing regarding geophysics. Being a geologist, I would like to say that geophysical studies are mostly dependent on first two of the four fundamental forces. I hope the four fundamental forces must be known to everybody, whoever especially working in geophysicist, geology or physics background. So that is gravity, electromagnetic. Electromagnetic is the fundamental, which comprises of electrical and magnetic as well. But fundamentally it is called electromagnetic. The nuclear force. Nuclear force further subdivided into strong nuclear force and weak nuclear force. So among that, geophysics mostly deal with gravity and electromagnetic interactions, which produce long range forces whose effects can be seen directly in the everyday life, especially in mineral exploration, for subsurface exploration, subsurface understanding. So long range things are required, whereas that strong and weak nuclear forces are not directly involved in geophysical exploration as such. Of course, they are also important in their own field, and electromagnetic forces occur between any two charged particles. Electrical forces, attraction between particles with opposite charges, and repulsion between same charge particles, while magnetism is an interaction that occurs exclusively between charged particles in relative motion. So these two effects combine to create electromagnetic fields in the vicinity of charged particles, which can accelerate other charged particles. So with this background, we shall start our conceptualization, visualization regarding skin depth or electromagnetic signal attenuation phenomena. In this diagram, we can just have a look regarding electromagnetic radiation, how it is oscillates. Electrical field and magnetic field oscillation is normal to each other, and these are the wavelength, and this is the propagation direction of electromagnetic radiation. Okay, now while going into detail about skin depth, we must understand a fundamental thing, that is a number, particular number, which is called Euler's number, or it can be pronunciation maybe like Euler's number. What is that? It is a fundamental constant that appears in a wide range of mathematical and scientific contexts. That is called E. Sorry, E. I have pronounced doubly. So it is making it one of the most important and ubiquitous constant in mathematics. Euler's number E is a numerical constant used in mathematical calculations, and most of the times it used as base of log. So the value of E is 2.718281 like that. So just like pi, E is also an irrational number whose logarithm gives the value as 1. that is log E equal to always be 1. So that E value is indeed will be useful in defining skin depth. How? Let us see. So let us define the skin depth. What is skin depth? We shall this is the in this video, it is fundamental video. Please stay tuned, it is very interesting. You can visualize from bottom of your heart. So skin depth is the depth at which EM signal attenuates to 1 by E. So 1 by 2.78 dot dot dot, that value I have shown, no? So that is indicating 37%, 0.37. 1 by 2.78, this value 1 by 2.71828182845 dot dot, automatically it will come 0.37, that is 37%. So the depth at which electromagnetic signal, naturally at the surface electromagnetic signal, if we consider 100%, so when it will at certain depth, when it is becoming 37%, that particular depth is called skin depth. That is 1 by E equal to 37%. So skin depth is typically measured in meters and is related to the frequency of EM wave and the electrical conductivity of the media. Media means here in geological exploration context, geophysical context, it is geologic materials, minerals, rocks. The EM wave is propagating through that materials, and so that material property will also play important role. Their conductivity will be coming into the picture. I will come into the mathematical expression of skin depth, which is 500 square root of 1 by sigma F. What is sigma? Sigma is the conductivity of the material and F is frequency, okay, electric frequency. So from this equation it reveals that skin depth is inversely proportional to that conductivity and frequency. So with increasing conductivity, skin depth will be decreased. With increasing frequency, skin depth will be decreasing. So higher electrically conductive earth materials and higher frequency EM, that is why we'll show shallow EM wave penetration. Now further if we see, let us elaborate this definition. In general, AC current is distributed within a conductor such a way that current density is largest near the surface of the conductor and decreases exponentially. So there is the importance of function of E. It decreases exponentially with depth in that conductor. So it is caused by opposing eddy currents induced by changing magnetic field resulting from alternating currents. As I told, alternating current is required, AC current, and in which always electric field keep on changing and which also responds in changing magnetic field, and due to that changing magnetic field secondary current will form, that is called eddy current. And that eddy current, what that will do, it will obstruct the primary current. So that balance will be the main property for measuring skin depth. I'll come into detail with picture, pictorial depiction. So the electric current flows mainly at the skin of the conductor. Conductor means, let us assume about a wire, metallic wire, electrical wire. Okay. So between outer surface and certain level called skin depth. So in the wire at the surface maximum current flow, and up to certain depth, that is skin depth, here it becomes 37%. At the central part it is very less deep because of eddy current, which is prominent with balance. So this effect was first described in a paper by Horace Lamb in 1883 for the case of spherical conductors and was further subsequently generalized to conductors of any shape by Oliver Heaviside in 1885. This is just for extra information. Now let us understand the cause of skin depth. What is conductor? See, here I have given one picture. Everybody must have seen this electric wire, how it goes. So conductor typically is in the form of wires which are used to transmit electric energy or signal. So these are conductors. These wires are conductors. Now have a closer look within this conductor. These are conductor wire. Further zoom in. This is a outline of conductor wire. Maybe it is cylindrical. It is outline. This section is circular. Within the circular, if we assume maximum current means 100% means flowing at the surface, so this delta will be a certain depth at which it is becoming 37%. In the central part, current flow is negligible. So most of the currents are flowing in and around the surface. So that particular depth from the surface of the wire inside the material, when it becomes 37%, that particular depth in terms of delta will be regarded as skin depth. So AC current density decreases exponentially from the surface towards inside, and skin depth is where that current density is just 1 by E, that is 37% of the value at the surface. So it depends on the frequency of the current and the electrical and magnetic properties of the conductor. Distribution of current flow in cylindrical conductor is shown here in by this section. So further, what is the cause in terms of proper explanation? If we see, when AC current in conductor produces a magnetic field in and around that conductor, so the intensity of current in the conductor changes, and with that changing, magnetic field also changes, and the change in magnetic field in turn creates an electric field that opposes the changes in current intensity, and this opposing electric field is called counter electromotive force or back EMF, and the back EMF is strongest at the center of the conductor, okay, allowing current only near the outside the skin of the conductor. So inside the conductor inside the conductor at the central part, this opposing or back EMF is prominent, whereas primary current is found along the superficial portion. So that is the reason. Secondary one is mostly dominating inside at the central part, okay. So an alternating current may also be induced in a conductor due to an alternating magnetic field according to the law of induction, okay. So AC current is must. Over 90%, 98% of the current flow occur within a layer 4 times the skin depth from the surface. So from the surface at skin depth, it is becoming 37%. Further, skin depth multiplied by 4, there it is become 98%. So practically at the center, exact central portion, there effectively no current flows, and this behavior is distinct from that of direct current, because in case of direct current, that current is distributed evenly over the cross section of the wire. Central part, skin, superficial portion, everywhere same current will be observed in case of direct current, unlike AC. In case of AC, at the surface maximum, with progress towards center, it drastically reduces exponentially, and 4 into skin depth, 98% current, 98% current is flown. Beyond that, 4 multiplied by skin depth, beyond that particular 4 multiplied by skin depth, practically it is very much negligible current flows in case of AC. Now cause of skin depth is further pictorially depicted here. Let us assume this is the one wire cylindrical portion. This is the wire unit portion of an wire. So when an AC current, for example this I, flows through the conductor, it induces a magnetic field here perpendicular to this, as I have discussed at the beginning itself, perpendicular to each other, electric field as well as magnetic field. So then H, that magnetic field further induces circulating eddy currents. This is IW, okay, which practically cancels the current flow in the center and reinforce it near the skin. So IW usually prominent. It is maximum in the central part of the wire. So I will be practically balanced by IW in this central portion, whereas this superficial portion, maximum I will be flown. Here in this middle portion, IW minus I, sorry, I minus IW. This is very much negligible. So that is the reason. With inside the conductive material, current flow drastically reduced, exponentially reduced. Further, once if we see the mathematical expression of skin depth, you can visualize this delta skin depth equal to 500 or 503 square root of 1 by f sigma, or 503 square root by 1 rho by f. This sigma means conductivity, so rho means 1 by sigma, that is resistivity, and f means frequency. Here we can see with depth, when f more than f dash, for example, so f means higher frequency, it is inversely proportional, no? So skin depth for higher f, higher frequency will be less compared to skin depth for less frequency. Okay, so this depth will be more when f is less, inversely proportional. Here electromagnetic and electrical and magnetic field is shown, and it can be seen exponentially decaying Jx is the current. Okay. If we we can have that amplitude versus depth plot also. By this also you can understand, can be visualized. Skin depth will be this portion, where it will become 1 by E. This is depth, this is amplitude. So here this point is indicating 37%, that is 1 by E, 37.37. okay. So this depth was amplitude, so at this delta depth it is becoming 0.37. so this is the skin depth. So skin depth reduces the effective cross section of the conductor and thus increases its effective resistance due to this that function. So for example, at 60 Hz in copper wire or copper, skin depth is about 8.5 millimeter. At high frequency, skin depth becomes further much smaller. Here I have taken some reference from different materials to understand the importance in geophysical exploration. This table shows the variation of skin depth in certain rocks and other earth materials, and this means to serve as a general guide, as rock types are classified by range of physical properties values which can lead to order the magnitude difference in skin depth. See here, depending upon the frequency, like 1 hertz, 1 kilohertz, 1 megahertz, 1 gigahertz. So with increasing frequency, how skin depth varies, beautifully it is depicted. Okay, sorry. Beautifully it is depicted. Now I'll show another thing. It is attenuation. Mu means attenuation. Now just for understanding, in case of air, skin depth, this is infinite. So air is not measurable thing. Now seawater, in case of 1 hertz, 277 meter. With increasing frequency, it is decreasing 8.76, 0.77. Now for example, let us see this magnetite scan or sulfide scan. Here it will be more important. It is known, this is conductivity of the material. For example, magnetic 100 sievert per meter like this. So here it is 36 meter in case of frequency of 1 hertz. With increasing frequency, the skin depth decreasing. Okay, so this is very important. Once we will be having such kind of information, it will be very much helpful in geophysical studies. For example, here this slide is explaining very well the importance of skin depth in geophysical exploration. I will just go through so that it is very legible for everyone. For example, depth of investigation. Okay, so does skin depth helps in defining depth of investigation for electromagnetic methods like in geophysics instruments such as GPR or ground penetrating radar, electromagnetic induction sensor or resistivity meter use electromagnetic waves to probe the subsurface. So understanding the skin depth is crucial for interpreting the depth at which these methods are sensitive. For example, low frequency electromagnetic methods may penetrate deeper, making them suitable for exploring deeper resources. Similarly, mineral discrimination. As I have shown that this table, different subsurface material have varying electric conductivity. And depending upon the conductivity, what will happen? By considering that skin depth, geophysicists can tailor the frequency of the electromagnetic waves used in exploration to discriminate between different types of materials. This is essential for distinguishing between rocks, sediments, water, and other subsurface features. Further, exploration for resources. The skin depth concept helps in selecting appropriate frequencies and methods for efficient exploration for minerals, oils, and waters. So these different material property, minerals, oils, and water will be having different frequency, the conductivity, and in terms of conductivity, automatically corresponding skin depths will be varying. So accordingly, according to that, frequency will be accordingly has to be selected, and it will be helping guiding that further exploration. Now further mapping of geological structures. Understanding the skin depth is crucial for mapping as well, because geological structures, subsurface layerings, geophysicists can create detailed images on the subsurface, and it can reveal fault, folds, intrusion, etc. Further, environmental and engineering application also. The skin depth concept is essential for designing surveys that provide relevant information at the desired depth for investigating contamination, plumes, and evaluating the stability of construction sites. So these are the primary things which are essential, essentially useful when skin depth concept is clear. So that is the importance of skin depth. Further, there in this context, skin depth will be relevant in mostly in electromagnetic surveys, and further, in case of electromagnetic survey, several principles, fundamental principles must be clarified. So the three fundamental laws, one is Faraday's laws, Ohm's laws, Ampere's, all act together, and these fundamental laws will be understanding legibly in the next video. So please stay tuned, keep on searching these things. I'll be available with you soon. Thanks for watching. Thank you.